Welcome to Integration by Parts Day 1 Notes. Integration by parts is based on the formula for the derivative of the product. The derivative of the product of two functions is the first times the derivative of the second plus the second function times the derivative of the first. We'll call them u and v. So we have u dv dx plus v du dx. We can write this as d of uv equals u dv plus v du. We can think of that as multiplying it both sides by dx. And with this formula then we could isolate u dv on the left, and I'm just going to change this a little bit with the properties of equivalence, writing u dv equals d of uv minus v du. And then I'm going to integrate both sides. The integral of u dv is going to be the integral of duv minus v du. And integral of the difference is the integral of, is the difference of the integrals. The integral of u dv then could be written, rewriting the integral of duv as just uv, we come up with the formula for integration by parts. We're going to try and consider when we're integrating a product of two functions, one of them as function and the other one as a derivative of a function. We might consider integration by parts when we're integrating what looks to be the product of two functions. For example, we might integrate x cosine of x dx. Now we're going to try and think of this as a product of a function and the derivative of a function. And notice we're going to need u, v, or u, dv, v, and du. We're going to need all these four parts to do integration by parts. So we'll call u either x or cosine x, or we could call it 1 dx and dv, or we could call it 1 and dv x cosine x dx. That would bring us back to the original integral, but what I'm getting at here is that it is somewhat arbitrary and you may not be sure at first glance what to choose. That's okay. That's the situation when you first start doing integration by parts. If I do choose u to be x, du is going to be dx, and if dv is cosine x dx, v I believe must have been the sine of x. Now I'm not going to write every antiderivative. I'm not going to put plus c here and deal with that. There's no constants included here in my. I'm not saying I have every thing whose derivative is cosine x dx, but I have something with a zero constant. So now I'm going to plug them into this formula, and I'm going to say that the integral of x cosine x dx, which is u dv, is going to be uv minus the integral of v du. What's happened here with this substitution, I still have an integral to do, but it's something different, and in fact it's something simpler. I can do this by inspection because I believe that the integral of sine x is negative cosine x. And so I have the solution or rather I have successfully found the antiderivative of x cosine x dx. This is example 1 in the notes. There's another one, example 2, and in this case we're trying to integrate x to the 6 ln of x. Again, we have to make a choice, and there's many options, arguably. We have to make a choice of u and dv. Remember, the formula is the integral of u dv equals uv minus integral of v du. If I let u equal ln of x, then dv must be x to the 6th dx. Okay, you might say, wow, I wouldn't have known to choose that way. Or why not choose, say, u equals x cubed ln of x and dv equal to x cubed dx. Those are certainly ways to factor x to the 6 ln of x dx. But as you get used to this, you'll see when you've made pretty quickly when you've made a good choice for u and dv. And if you made the wrong choice and you can't continue, or the integral that you're left with is more difficult than you started with, that's a clue that maybe you should have chosen differently. Okay, I have to generate du and v. Here I'm not adding a c, a constant here, I'm just using that antiderivative with a 0 constant. So, I'll just use the formula and write uv, x to the 7th over 7, ln of x minus integral of v du, which seems to be x to the 7th over 7 dx over x, which is x to the 6th over 7 dx. So, my evaluation depends on me being able to integrate x to the 6th over 7, which I can do. We all can do that with the methods we have so far. And so we're done. Other choices may have given you a problem actually coming up with the antiderivative of v, or if you form the integral v du and you can't integrate it, or it's more difficult to integrate or more complicated than your original original integration problem, that's a clue that maybe you should choose different. But if you choose a u and a dv and then generate du and v and put them in the formula, maybe this integral will be easier than your original one. In this case, I could do it by inspection. And that's how integration by parts works. And that's the end of the notes. Please try examples 1A and 1B for homework for day 1 of integration by parts.